It is common knowledge that mayflies have short lives. Even their scientific name, Ephemeroptera, pretty much means fleeting or ephemeral wings. The trouble with a great deal of common knowledge is, it can often be sadly incomplete and regrettably misleading. Such is the case with the mayflies. While it is true that the adult stage tends to live for a matter of days, or even less in some species, the adult stage is just a fraction of the creature's actual life, a perishingly small fraction at that. The balance of a mayfly's existence is not spent in the air, but rather in the water. The adults are specialized for little more than reproduction and distribution. Granted, some of these adaptations are quite extreme in their own right. In many species, the adults lack functional digestive systems and do not feed. Legs may often be reduced and effectively vestigial. Eyes, on the other hand, can be remarkably well developed. The males of certain mayfly species have eyes that are oddly and grotesquely shaped to maximize their chances of finding a mate during their brief adult lives. For a mayfly, there is little more to their adult life than simply finding a mate and producing the next generation. It is a fleeting dream in comparison to the vast majority of the creature's lifespan. So far as the mayflies are concerned, it is the larval form that is adapted for actually living a life. To understand mayfly larvae, one must understand something of insect metamorphosis. Very broadly speaking, there are two sorts of metamorphosis to be found among the insects. There are a number of exceptions to this general rule, but it is still a useful starting point. The majority of insect species follow a holometabolous pattern, in which the larva is very different from the adult. Common examples include the grubs that grow into beetles, the caterpillars that become moths, and the maggots that develop into flies. The larval form in this sort of insect is generally a soft-bodied creature with a hydrostatic skeleton and simple eyes. Such eyes can detect and distinguish general light levels, but they cannot form proper images. The legs are either much reduced or altogether absent. Any tissues that develop into adult wings are hidden away within the body. With all of these anatomical differences, there is an intervening pupal stage to allow for proper development into the adult form. The other major sort of insect developmental pattern is the hemimetabolous pattern. Here, the larvae are more similar to the adults, and there is no intervening pupal stage. Like the adult, the larva has a rigid exoskeleton with well-developed legs. The eyes are compound eyes capable of forming proper images. The developing wings are visible as external wing pads on the thorax. Such larval forms are often known as nymphs. In many of the hemimetabolous insects, such as cockroaches and grasshoppers, the nymphal stages live in almost exactly the same way as the adults. They inhabit the same environments, eat the same foods, and look very much like smaller, wingless versions of their parents. However, with some groups, the larvae can take on remarkably different forms from the adults and live in completely different ways. This is especially apparent in 3 orders of hemimetabolous insects with nymphal stages that live in water. One of these orders is the Plecoptera, commonly known as the stoneflies. Another is the Odonata, which contains dragonflies and damselflies. The third is the Ephemeroptera, also known as the mayflies. A mayfly larva can be distinguished by a couple of significant features. First, most larvae have 3 long, thin appendages arising from the tip of the abdomen. These segmented appendages are a pair of cerci and a terminal filament in the middle. They act as sensory organs, making it a bit more difficult for potential predators to sneak up on the creature. This is fairly important as these little insects are commonly eaten by a wide range of aquatic animals. Living in the water requires some form of suitable respiratory adaptation. In the case of mayfly larvae, the adaptation takes the form of several pairs of gills. Like the gills of other aquatic animals, the mayfly's nymphal gills are respiratory structures with relatively large surface areas that allow for oxygen uptake from the surrounding water. In the case of mayflies, these gills take the form of 2 rows of small articulated appendages, 1 row on each side of the abdomen, usually located on the back. In some species, the gills have simple flattened shapes resembling small leaves. In other species, the gills are branched and can take on a rather fuzzy appearance. Regardless of their precise form, they all have an unusual structural quirk. Each gill contains minuscule air tubes. These air tubes connect to a network of air tubes inside the insect body. This network is known as the tracheal system, and it allows for rapid oxygen delivery over small distances. In most insects, the tracheal system simply connects directly to the surrounding atmosphere. In the case of aquatic mayfly larvae, this wouldn't really work. So, the air tubes are entirely separate from the outside. Oxygen diffuses into the gills and into the air tubes within these gills. It then spreads rapidly through the rest of the body via the tracheal system before diffusing into the various body tissues. Since running water generally contains more oxygen than standing water, most mayfly species are found in rivers. As their gills need to be highly permeable to function properly, they are often quite sensitive to chemical contaminants. Some specialists can reasonably estimate the water quality of a river or lake based upon what sorts of insect larvae they find living there. While breathing is certainly important, it is not the only concern for mayfly larvae. As most live in rivers, the current of flowing water is a more or less constant issue. In the more upstream environments with strong water currents, this is especially challenging. Imagine spending your life in a narrow valley filled with gigantic boulders where there is a constant gale of hurricane-force winds. That is something like what many mayfly larvae must deal with every day. The current here is strong enough to sweep everything away and wear rocks down into smooth pebbles. Such places are technically known as lotic erosional habitats. In this sort of habitat, there are a couple of basic options for the resident insect larvae: clinging or swimming. In the former case, the insect clings to the rocks to avoid being swept away and clambers about carefully on the riverbed. This pattern is exemplified in the family Heptagoniidae, which are sometimes called flat-headed mayflies. This name refers specifically to their larvae, which have flattened bodies as well as flattened heads. This allows them to hide away beneath the rocks in the riverbed, away from the current. Even on exposed surfaces, this flattening greatly reduces the current's effect on them. They tend to feed on bits of detritus or scrape algae off of the rocks as a food source. Some mayfly larvae take the swimming option instead. One of the largest families is the Betidae. These are relatively small, common mayflies. The larvae are strong swimmers and tend to cling to various surfaces between their jaunts through the water current. These mayflies are sometimes known as small minnow mayflies, largely because of this swimming habit. Further downstream, where the water flow is slower and more gentle, the riverbed tends to fill with sand and silt. This is a lotic depositional habitat. Here, the current is less of an issue, so the insects take on other habits. There are some species with larvae that sprawl out on the sandy or silty riverbed, spreading their legs out over the soft sediment to avoid sinking in. The larvae in the family Canidae live as sprawlers of this sort. They are sometimes called small square-gill mayflies. The gills are largely hidden away beneath a pair of sturdy, roughly rectangular covers. This keeps them protected from the potentially abrasive sediments. For many mayfly larvae, sediment is a food source as well as a habitat. Many species sift through the silt in search of tiny bits of food. In contrast, some species use various brushes and bristles to filter food particles directly from the water. One example of these filter feeders would be found in the larvae in the family Oligoneuridae. These insects strain particles from the water with special brushes on their legs. Perhaps not surprisingly, they are often referred to as brush-legged mayflies. Rather than staying above the sediment, some varieties of mayfly larvae burrow into it. There are a number of mayfly families with larvae that specialize as burrowers. The Polymetarsiidae are sometimes known as pale burrowers, and the larvae have sturdy front legs and a pair of downward curving tusks extending from their heads. The family Ephemeridae, sometimes called burrowing mayflies, are quite similar overall, but their tusks curve upward rather than downward. A good example within this burrowing family would be the species Hexagenia limbata. This creature digs a U-shaped burrow and uses 7 pairs of feathery articulated gills to create a slow water current through this burrow. This helps it to breathe more easily, and it also brings in a steady supply of detritus for the creature to feed on. Some of the burrowing mayfly larvae do not excavate proper burrows. Instead, they simply bury themselves shallowly in the sediment with only their eyes and gills exposed. This is seen in the family Ametropodidae, sometimes called sand minnows. One of the most unusual mayfly larval forms is seen in Dolania americana in the small family Benhingidae. This species is commonly known as the American sand-burrowing mayfly, and the larva is specialized to more or less swim through the sand. It is roughly cylindrical, with gills on the underside of the abdomen rather than its back or sides. It is a bristly creature with spines on its head and thorax, and antennae tucked away beneath the head. It burrows through sandy riverbeds, seeking out midge larvae to feed on. As odd as the larval form is, the adult is fairly unusual in its own right. By some accounts at least, they live for roughly half an hour after emerging from the water, just barely time enough to mate and lay their eggs before they die. This may be the shortest adult lifespan of any known insect. There are a few other oddities worth mentioning among the mayflies. The family Ephemeralidae has a number of large species, with larvae that have an almost monstrous appearance. This is reflected in their common name, the spiny crawler mayflies. In some cases, these larvae are also carnivorous, with sturdy front limbs modified to capture and hold prey. In contrast, the family Batiscidae has larvae that are oddly armored, with spines on their head and thorax. They are sometimes referred to as armored mayflies. Despite their sturdy appearance, they are not carnivorous and appear to feed on detritus like the larvae of most mayfly species. Another closely related armored family is the Prosopistomatidae, with the single living genus Prosopistoma. The larvae in this genus are lacking in spines, but they are remarkably heavily armored. At a glance, they look more like little beetles than mayflies. No matter how strange the larval form might be, eventually the surviving larvae metamorphose into adult mayflies. There we can find one last little surprise from this order. In the vast majority of insects, there is a winged adult form, technically known as the imago. This final life stage generally arises from either a nymph or a pupa, depending on the group. With mayflies, it is a little different. The larvae leave the water and molt into a winged form known as a subimago. In most species, this creature tends to have fairly drab coloration and clouded wings. Shortly after emerging from the water, this stage molts again into a second winged form. This is the proper imago stage, and it tends to have clear wings and more striking coloration. There are sometimes other modifications as well, like longer cerci on the abdomen or more extensively modified eyes in males. In any case, it is this final imago stage that concludes the long life of the larval mayfly. Several months and sometimes years of aquatic existence come to an end with a fleeting, frantic race to reproduce. Even if such efforts are successful, all that remains afterward are a number of viable eggs in the water and a couple of fresh mayfly corpses. Such is the ephemeral dream of the adult mayfly, a most unusual conclusion to its more lengthy and substantial larval existence. Thank you for listening. I hope you have enjoyed this brief glimpse into the more unusual side of the natural world. If you wish to know more, here are a few things that might be worth looking into. If you found this enjoyable, feel free to leave a like. If you think others would enjoy this content, by all means, share. If you have something to say or ask about, honest comments are always welcome. If you wish to see more from this channel, a subscription would be most helpful. Until next time.